Assalamu alaikum. You are watching my YouTube channel Share Views. You can watch lot of interesting videos like technical knowledge, automobile sales and views, Islamic, Pakistan cultures, safety and health and much more. If you like my channel, please subscribe, like and share it. Thank you. So today my topic is steam generator. In other words, it's called boiler. On this topic, 3 PPT slides are available on my LinkedIn, Facebook and SlideShare sites. But when I started to make the videos on these slides, I faced the difficulty to reduce the length of the video. So I decided to partition of these PPT slides in the 3 parts. I also thank to CapCut to use the audio voice of male professor on my slides because I am not have a stamina to record lengthy videos. Thank you.
Hello, in this session will try to explain about steam generator boiler. Due to length of said presentation, I decided to divide it in 3 parts. Part 1 covered the introduction and types of steam generator. Part 2 cover about the parts of steam generator and its accessories and auxiliaries, and Part 3 cover the efficiency and performance. Part 1 Episode 1. Steam fundamental. Steam is uniquely adapted by its availability and advantageous properties for use in industrial and heating processes and in power cycles. The fundamentals of the steam generating process and the core technologies upon which performance and equipment design are based are described in this section. What is steam? Steam is an invisible gas that's generated by heating water to a temperature that brings it to the boiling point. When this happens, water changes its physical state and vaporizes, turning from a liquid into a gas. How the energy of steam is used. The uses for steam are many and varied. Like 1. Power generation. 2. Industrial process. 3. Heating. From the plastic and vinyl components of our automobiles to the paints and stains we use on our homes to the preparation and presentation of the food we eat, steam is used in a variety of ways to make our lives more comfortable and convenient. What is a boiler? A boiler is an enclosed vessel that provides a means for combustion heat to be transferred to water until it becomes heated water or steam. Or, steam generators, or boilers, use heat to convert water into steam for a variety of applications. What is a boiler capacity? Boiler loads, or the capacity of steam boilers, are often rated in boiler horsepowers bhp, lbs, of steam delivered per hour, or BTU. Large boiler capacities are often given in lbs, of steam evaporated per hour under specified steam conditions. Boiler capacity, boiler horsepower, bhp. The boiler horsepower bhp is the amount of energy required to produce 34.5 pounds of steam per hour at a pressure and temperature of 0 sig and 212 of, with feed water at 0 sig and 212 of. A bhp is equivalent to 33,475 BTU HR, or 8,430 kcal per hour, and it should be noted that a boiler horsepower is 13.1547 times a normal horsepower. 1 horsepower boiler equals 33,445.6 BTU mean HR. Equals 140,671.6 calorie, min thermo. Equals 140,469.4 calorie mean, min. Equals 140,740.3 calorie 20 oct, min 9.8095 x 101 org, sec. Equals 434,107 foot-pound force, min. Equals 13.1548 horsepower mech. Equals 13.1495 horsepower electric. Equals 13.337 to horsepower metric. Equals 13.1487 horsepower water. Equals 9,809.5 joule sec. Equals 9.8095 kilowatt. Horsepower can be converted into lbs of steam by multiplying HP with 34.5, or sometime called 1 bhp equals 33,479 BTU HR. Introduction: Steam to power generation. Industrial process and heating. This diagram shows the process of steam. Classification: This diagram classified the steam generator. 1. Type of fuel like fossil, waste, nuclear, etc. 2. Tube contained like water tube or fire tube. 3. Furnace like natural, pressurized, induced balance. 4. Method of firing like externally, internally. HRSG. 5. Water circulation like a natural, forced. 6. Pressure of steam like low, medium, high, critical and supercritical. Classification of fuel. This chart shows classification of fuel which are used in boiler. 1. Fossil fuel like oil, natural gas and coal. 2. Waste heat like gas turbine exhaust, diesel or gas engines exhaust flue gases. 3. Waste fuel like biomass, bagasse, rice husk, wood pellets, forestry residues. Mill residues, agricultural residues, chemical recovery fuels, animal waste, dry animal manure. Wet animal manure, dairy manure, slurry. 4. Nuclear fuel like uranium and fission. This slide shows you types of boilers. Point 1. Fire tube boiler. 2. Water tube boiler. 3. Packaged boiler. 4. Fluidized bed FBC boiler. 5. Stoker-fired boiler. 6. Pulverized fuel boiler. 7. Waste heat boiler HRSG. 8. Nuclear steam generating systems. Classification based on pressure. Point 1. Low pressure boiler under 20 kilograms per square centimeter. 2. Medium pressure boiler 20 to 75 kilograms per square centimeter. 3. High pressure boiler over 75 kilograms per square centimeter. 4. Critical and supercritical. A critical boiler operates at the critical pressure of water, which is around 221 bar 20 to 0.1 megapascals, while a supercritical boiler operates at pressures above this critical pressure, meaning it operates at a pressure higher than 221 bar. Fire tubes versus water tubes boilers. Fire tubes boilers has a large volume of water, therefore more flexible and can meet the sudden demand of steam without much drop of pressure. Fire tubes boiler is rigid and of simple mechanical construction, so greater reliability and low in first cost. Fire tube boilers can be made in smallest sizes, therefore simple to fabricate and transport, occupies less floor space but more height. Due to mostly externally fired water tubes boilers, so furnace can be altered considerably to meet the fuel requirements. Water tubes boilers are more readily accessible for cleaning, inspection and repairs compared to the fire tube boilers. Modern trend is in the favors of water tube boiler due to continuous increase in capacities and steam pressures. Typical fire tube package boiler. This slide shows you the typical package type fire tube boiler. Fire tube boiler. Relatively small steam capacities 12,000 kilograms per hour, 3,500 to 35,000 pounds per hour, 120 bhp minus 1,200 bhp. Low to medium steam pressures 18 kilograms per square centimeter, 350 sig, operates with oil, gas or solid fuels. Scotch Marine, most popular, 2, 3, and for past designs. Constant pressure with wide load fluctuations. Fire tube boiler, simple vertical boiler. Cochrane boiler, locomotive boiler, Lancashire boiler, Cornish boiler. Fire tube boiler, simple vertical boiler. The image shows the simplest form of an internally fired vertical fire tube boiler. It does not require heavy foundation and requires very small floor area. Parts: cylinder shell, cross tubes, furnace or firebox, grate, fire door, chimney or stack, manhole, hand hole, ash pit. Fire tube boiler, Cochrane boiler. It is a multitubular vertical fire tube boiler having a number of horizontal fire tubes. T is the modification of a simple vertical boiler where the heating surface has been increased by means of a number of fire tubes. Parts: shell, crate, firebox, flue pipe, fire tubes, combustion chamber, chimney, manhole. Fire tube boiler, locomotive boiler. This is a typical locomotive boiler diagram. Fire tube boiler, locomotive boiler, and other typical view. Fire tube boiler, Lancashire boiler. It is a stationary, fire tube, internally fired boiler. The size is approximately from 7 to 9 meters in length and 2 to 3 meters in diameter. Fire tube boiler, Cornish boiler. It is a similar type of Lancashire boiler in all respects, except there is only one flue tube in Cornish boiler instead of two in Lancashire boiler. The diameter of Cornish boiler is generally 1 meter to 2 meters and its length varies from 5 meters to 7.5 meters. The diameter of flue tube may be 0.6 times that of shell. To be continued in next video.